page something. Page 8. So, these pathway questions used to...
Out of curiosity, why did it assign those
because I think you could figure it out that you could wait. All right, good call. Okay, so for these ones, we can actually count the pathways by doing it properly like pathways, but it's not in a pathways unit, is it? It's in a perms and comms unit. So we have to be able to do this using like perms and comms or something like that, correct? I'm going to show you how we can actually get it correct by doing the pathways so that you believe me instead of just trusting me, you actually believe why. But we don't actually have to do it the pathways way, okay? So I'm going to show you how you can count pathways. You are not going to do this. Do not start writing this. Don't be like, maybe I need to know. You don't, okay? Do not do this. All right. So we're going from A to B, and we're never allowed to like circle back, or else it would be infinite. You'd just be like circling the block and never getting to B, correct? So we're always working our way from one letter to another. And I'm going to write the pathways, but you're not writing this because you don't know how to do it. You don't have to know how to do it this way. It's just proving that when I do it with perms and comms, it makes sense. Okay, so if I'm going from A to B, I have one way that I can get to this path. I go one way. And then I get to here one way. I can literally just walk there. Now some people are like, well, I could go this way, this way, this way. And then, no, you're backtracking. This is backtracking. So it's one, this is one. I have one way to get here. I can literally just walk there. Or I have one way to get here, and one way to get here, one way to get here, one way to get here, and one way to get here. But I can just walk there, correct? Just shoop, yes? Now, when we want the total number of pathways, we just count how many pathways come into the intersections, and then we'll starting to sum up how many pathways we have to get there. So for example, this intersection here, I have one pathway coming in and one pathway coming in, which is a total of 2 pathways coming into here. We agree? Then I have 2 coming in from the left, 1 coming in from the top, so that's 3 total pathways. 3 and then 1 is 4, 4 and then 1 is 5, 5 and then 1 is 6. I'm going to start aggressively doing this fast so that people don't start copying it down. 1 and 2 is 3, 3 and 3 is 6, 6 and 4 is 10, 10 and 5 is 15, 15 and 6 is 21, 1 and 3 is 4, 10, 10 and 10 is 20, 20 and 15 is 35, 35 and 21 is 56. 4 and 1 is 5, 5 and 10 is 15, 35, 70, 126. Did that intentionally because you do not need to write this down. But it's 126 paths to get me from A to B. We agree? And you're like, there's got to be a better way. There is. It's not this way. So, paying attention, really easy, but easy to forget about this. And they give these every so often on the diploma, so we just need to know how to do them. But basically, from A to B, we're only allowed to go down and right, because we're not allowed to backtrack. We're not allowed to go up or left, right? We'd be backtracking. Do we agree? So we're going to count how many downs we have. We have 1 down, another down, another down, and another down. Do we agree? Okay. And then rights, we have 1 right, 2, 3, 4, 5. So if I just treat this like the word der, and figure out how to, and figure out how to, many ways we can rearrange that, we have an answer. So I have the word duh, We agree? If I have this, you can write down the der part. And I'm not even joking. The D, 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 R, 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 and the der. If I was rearranging salsa like we did in the question at the beginning, I divided by 2 factorial and 2 factorial because there's 2 A's and 2 S's. And I could technically have divided by 1 factorial for the L. I could, right? There's just no point in doing that. In this case, what am I going to divide by because of my repetitions? 4 factorial because of the 4 D's, and 5 factorial because of the 5 R's. We agree? Now, when I did salsa before, the word salsa, I'm just going to show it over here. If I did S-A-L-S-A, if I wanted to just rearrange salsa, on the top I would have no restrictions, wouldn't I? So what would I have up here? 5, then 4, then 3, then 2, then 1, all over 2 factorial, 2 factorial, which is technically 5 factorial over 2 factorial, 2 factorial. I put the bottom in brackets because if you put it in your calculator without brackets, you can get the wrong answer. It's going to do order of operation, right? So in this case, I had salsa, which had 5 letters. In this case, how many letters are in dir? Ooh, did not mean to do that. There are 9. We agree? So I would technically go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, wouldn't I? But what is that? 9 factorial. Everyone type that into your calculator until you get 126. Why do I know the answer is 126? Because I'm doing that in my head? No, because I already did this. So I know that's where I need to get to. Right? Everyone is typing it in. The worst part are the people who never type anything in perms and coms and bomb their unit test only solely due to the fact that they do not know how to type this in. Is everyone getting 126? Now type it in without brackets. Humor me. Don't ever do this again after this moment. Just type it in without brackets. Because that's what happens on the test. It's the saddest thing. Did you use fraction button? Then you're golden. You don't need brackets. If you use the fraction button, it makes it so that there is bracket. That it does the fraction first, right? So it order of operations that way. But if you just put it in without the fraction button, you have to use brackets. Yeah. So it'll make it ginormous because it's going to do 9 divided by 4 factorial. 9 factorial divided by 4 factorial, and take that answer and then multiply it by 5 factorial, which is not at all what you wanted to do. If you use the fraction button, you have bypassed all problems and you're golden. If you do not have the fraction button, I apologize. You need brackets. Okay? Now, what happens with this next one? Paying attention? We're going to do each of these separately. So this is going to be pathway 1, and this can be pathway 2. Pathway 1, we have D, D, R, R. D, D, and R, R. So we're going to do that word off to the side first. Pathway 1. Okay? How do I find that one out? On the bottom, I'm going to have what? 2 factorial, 2 factorial, because of the DD and the RR. And on the top, 4 factorial. So I'm going to get 6. So there are 6 different paths that I can take to get to here. Nope, because you need to take these paths and these, like a path here and a path here to get me to here, right? If you say or, you could just take these paths and miraculously, poof, end up in B. Or bypass these ones and end up in B, which we can't do. So we always have to multiply. And the way I remember that is I'm like, how do I connect these? I connect these with a big dot, and a big dot is a multiplication, right? So I just connect them with a dot. Then we have to do the next one, part 2. Part 2 has D, D, R, R, R. Which is going to be 5 factorial over 2 factorial, 3 factorial. It's 10, I believe. Is 10? I think it's 120 divided by 12. And then we go 6 times 10, because we need pathway 1 and pathway 2 to get me to B, which is 60. Yeah? Okay, we're going to talk about the NPR formula. You need a separate sheet of paper out. We're going to discuss the NPR formula in our time constraints of life. It is on our formula sheet. NPR. It's not your formula sheet. The formula sheet's over here. So, if you look at the bottom left of your formula sheet, which you might want to have out if it's a handy, NPR is here. NCR is here. It explains that n factorial is everything when you start with a number all the way to 1. 0 factorial is 1. So you're going to go NPR equals n factorial over n minus r factorial. The P represents permutation. Okay? The only way we can use this formula is if there are not restrictions. So this is a permutation formula. But you can only use it when you don't have restrictions. So the moment you like sit people in a row and someone can't sit somewhere or someone has to sit somewhere, done. You can't use this formula. You have to like line them up with fundamental counterprinciple. Okay? The moment you restrict anything, this formula doesn't work, even if it is a permutation. And if I'm ordering someone in seats, if I'm ordering them in seats, or arranging them in a seat, then that's a permutation. So the example I used here, where I have these 4 people and they're going to a movie and I'm arranging them in seats, that's a permutation because I'm giving them a specific order. If it's a photograph and I'm lining people up and someone has to sit in the middle, boom, permutation, yes, can't use the formula. Okay? All right. Now, what this formula is I'm going to explain it to you. So, we can only use it if we have permutations. There's a combination one if we have to have combinations. But I'm going to explain to you the difference because honestly, I 50-50 guessed at all times in high school. Like it was like, P. C. But I had no clue. That's never a good situation. That is just sadness. Okay? So, we don't want you in the same boat as me. My boat was a sad boat. We don't want you in that boat. We want you in a happy boat. What is this? No, it's 50. It's NPR or NCR. It's either perm or a com. You have a 50-50 guess. Okay. Paying attention. Not on phones, completely paying attention. I don't know what you're doing, but we need to. All right. I know, but I don't know what you're doing, but because you're not paying attention, even if it's on a calculator. It is not okay. Put your freaking calculator down now. Yeah. There we go. Now we have his attention. All right. So we have, yes, that was very good. She's getting very good at this. This is good. Okay. So we have 20 people. We're not writing anything. We are just paying attention because when we write, we don't listen as much. Okay? So we are just paying attention. We're not on our calculators. We're nothing. So we have 20 people. Paying attention? 20 people. All right? It is 20 because it just made it up in my head, and that's what came to me. Okay. There are 20 people on a committee. We're not writing this. We're just listening. Okay. We agree? 20 people. We're imagining them. Oh, there they are. Okay. 20 people on a committee. We don't even care what committee. We're like, is this a spirit committee? We don't care. They're just on a committee. Paying attention? Yes. Okay. In order for this to be a permutation, question, we have to be able to tell the difference of what you're choosing them for. So basically, the subcommittee that you pick from this needs to have like jobs or something. So an example would be, I have a 20-person committee. Everyone can visualize them. Yep, they're all different. Okay, there we go. We got our 20 people. Okay? I'm picking 3 of them to go on a trip. 3 people to go on a trip. I don't care what their names are. I just know they're 20 different people. Okay. I'm picking 3 different people to go on a trip. Paying attention? The trip is to Hawaii. You are welcome. Now, this is what I did not understand. You have to look at the people you are choosing, not the committee people. There's 20 of them. Great. Yeah, I don't care. We are picking 3 to go on a trip, okay? If the 3 you are choosing, which is going to be the R, do you see the R there? That's going to be the chosen people, the chosen ones. Okay, if the 3 people you are choosing, if their lives are different because of what you're giving them than each other, it's a permutation. Order matters. If the way you pick those 3, their lives are no different, order doesn't matter. So, let's go back to the scenario I gave you. I picked 3 people. They're all going to Hawaii. If I pick them first, second, or third, does it change their outcome? No, they're all going to Hawaii. So did the order in which I picked those 3 matter? No. So guess what that would be? That would be, we're not writing anything, we're just listening. That would be, I have 20, and I have C, 3. It would be a C, because the order in which I picked those 3 made their outcome no different. It might have made them a little bit more like, ah! By the time they got picked third, first person was like, boom, Hawaii. Third person was like, boom, Hawaii. But it took them a little bit of pressure, maybe a little anxiety, don't care. Their outcome was the same. Dumb Wagner in high school was like, but the 4th person didn't get to go. Order matters. And I was just like, no, it doesn't matter about the people who don't get to go. We don't care about that. They're sad. They're all sad. They all equally sad, unless someone hates Hawaii. But all we care about is the 3. Now, how could I change it? How could I change this so that the 3 orders actually mattered? Imogen.
The first person could get, like, I don't know, more, maybe better treatment or something. Like maybe they got a prize alongside that.
Right. So maybe they're all going to Hawaii, but the first person gets $200 of spending money, the second person gets $100 in spending money, and the third person gets a popsicle. Maybe you really like popsicles. Maybe you want to be the third person. Okay? Either way, does the order matter in which I pick those 3 if I make something different for each of them? Yeah. So in that case, it would be a 20 P3. Now, can you type 20 P3 in your calculator? Let's go. So we're going to type in 20. Thanks, Jackson. So we're going to go 20. And then remember where we went to find the factorial button? We're going to the same place. So we're going to go 20. And then we're going to go math over to probability and pick number 2.
So it's 20 NPR.
Yeah. So if you have the older calculators, it's going to say 20 NPR and then 3. Now, paying attention. This is 6,840. Now put in the 20C3. Let's make it make sense. 20 math C3. When we type that one in, we get 1,140. Now what does that number represent? That number represents the different number of ways I could pick 3 people to go and do that. Now why is the C one so much smaller than the P one? Right. Because if, let's for example, to go to Tyson, I'm going to break it. I can set it on the podcast. Make it go away. Let magic disappear. It's still there. I can see it. It's slightly better. Okay. So, why is the C smaller than the P?
Why is this C smaller?
Why is the C in combinations smaller than the P in permutations? I'm curious. Give her.
Well, it's because the P equals 6,840, but the C is only about 1,100 and something.
Yeah, true. One is larger than the other. Okay, but why? Humphrey's answer was true, but not helpful. Okay, so why is the C so much smaller? You said because the order didn't matter, correct? So when I have the three, let's think about this. So the three people I'm picking to go on the trip, these are the people. So we're going to take this row. We're going to take Tyson, we're going to take James, we're going to take Liam. Okay? Now, when it's a C, when I take those three, when I take these three, if it's a C, and I move them all around, wow, good catch again. So when I move them all around, does it make the outcome any different? If I go Tyson, and then James, and then Liam, then Tyson, James, none of those matter, correct? The order didn't matter. So that's why I get way less cases. Now, when I take them on the trip, and I give them $200, $100, or a popsicle, then the order matters. Now, Tyson, James, Liam is a different outcome than Tyson, Liam, James. Is a different outcome than James, Liam, Tyson. So there's way more outcomes that I could get, correct? So when it's a P, your answer is going to be larger than when it's a C. Now, this is the sad part. If you do not know the difference, you are literally guessing because they will put the P answer there and the C answer there. So you will feel okay about yourself either way, when maybe you should be sad. But you don't know because you don't know the difference. So the key part is to understand what the heck it stands for. Now, this is what I'd like you to see. In blanks, everyone paying attention? In blanks, P can be represented in blanks. We agree? Because I'm picking three people to go on a trip and I'm arranging them. And if I'm arranging them, I can put them in blanks, correct? I can put one person stand them here, put one person stand them here, put one person stand them here, correct? So I could say, hey, how many options do I have for the first blank with going to Hawaii and the $200? 20. Then that person gets to go. I've left one there, but that's my options. Remember, each blank represents one person, but 20 options. Left didn't understand that in high school. Now this one is what? 19. Then this one is 18. So what this actually is this number represents the number I'm starting with, and this number represents how many of them I'm choosing. So that's the three blanks, correct? Now people will try and do that with C. The moment you start doing this, everyone paying attention, because it's so sad when this happens on the test. The moment you do this, what are we doing? Are we not arranging those people? Are we not standing them in a spot? Are we not giving them a position? Yeah? What does C mean? There are no positions. So can I ever do this? No. Stop the madness. You will actually know that it's a combination. You will. You'll be like, I know it's a combination because order didn't matter. And then you'll do blanks. And I'm like, okay, but you just said it's a combination, you then did permutation blanks. Why are you doing that, son? Okay. So we're not going to do that. Now, how else could I ask this instead of giving different money? Well, what I could do is I have a 20-person subcommittee. Paying attention, you're going to tell me if it's permutation or combination. I'm not telling you which one. 20-person committee. I need a 3-person subcommittee. Boom. What is it? 20-person committee. I'm picking a 3-person subcommittee. Is it order mattering? Permutation? Do those three, the way I pick those three matter? Or do the way I pick those three not matter? It's a combination. It doesn't matter. I'm picking 1, 2, or 3. They get to be on the subcommittee. Did I give them jobs on that subcommittee? No. If I pick them first, second, or third, do they get to be on the committee? Yeah. Nothing changes. Now, how can I change to a permutation? I have a 20-person committee. I'm picking a 3-person subcommittee, and of that subcommittee, one is the president, one is the vice president, one's the secretary. The moment I give those positions jobs, you can tell the difference. Okay? So, what if I do this? Paying attention? There are 40 teachers, and there are 300 students. Okay? Paying attention? They're going on a trip to Texas. Just popped in my head. That's where they're going. You're welcome. Okay. They're going on a trip to Texas. Shh. Paying attention? If I pick 20 of them to go on a trip to Texas, how would I do that? 20 of them get to go on a trip to Texas. First off, I have to decide, is that a perm or a com? Right?
20 teachers and 20 students.
I didn't say any of that. I just said 20 get to go on a trip. First off, we have to decide, is it a perm or a com? It's a com. 20 get to go on a trip. I didn't give them jobs. If I was like, one gets to clean the toilet, one gets to order everyone around, one gets to just eat popsicles. One, I don't know why I'm bringing popsicles up, but it's hot in Texas. That's what I hear. Okay, so if they're just going on a trip, it is a C. correct? If I give them jobs to go on that trip or anything extra special, P. We agree? Now, I am choosing 20 to go on a trip. Am I choosing teachers or students? Did I say anything specifically about teachers or students?
No.
No, so how many do I have to choose from if I just say 20 get to go on a trip?
340.
340. And I'm going to, the faster you answer doesn't make it better. 340, and I'm going to choose 20. Now, could that mean that all the teachers get to go and the students are stuck home? Sure. Could it mean worse that all the students get to go and there's no teachers? Bless Texas. Good luck. All right. So if I don't say a specific number of each, this is where these people get this wrong way more than anything else. So if I don't say a specific number of each, I have to use the total, C20. We agree? Now, what if I say I need 4 teachers on the trip, 4 teachers and 16 students? Now what am I going to do? How can I guarantee getting teachers? Choosing from 340? Choosing from 40. If I want teachers, what do I have to choose them from? Teachers. If I want students, what am I going to have to choose them from? Students. So I'm going to go 40. Is it going to be a C or a P? 20 people still going to Texas. It's still a C. Didn't change. C4. What does and mean?
Multiply.
I don't know, I wasn't
Or
sure
it's
that
plus.
way.
And add look like best friends. Look, they're so close, don't they? They're so close they hate each other. Bad news bears. Bad, bad. Multiply.
How's the pasta?
Add goes with or. Please don't put a plus sign when it says and. Makes me twitch. Okay, this is from my head hitting the board. It drew extra stuff over here. Anyways, 40C4 and is multiply. Now, how many students are we choosing from? 300C16. So could I go like this? 40, 39, 38, 37.
No.
No, that is hurting my heart. That is literally making me so sad. My heart's breaking. That's what that is. Because the moment we put lines, we are doing what with these people?
Permutation.
We are permutationing them. It's a word I just made up. We are ordering them. We are arranging them. We are stacking them in a spot. We are giving them jobs, and they do not have jobs. Okay? All right. Let's look at cards. Okay? Now, the great thing about cards is, or the sad thing about cards is people don't play cards. Okay? The good thing about cards is cards are always, you know, you save 2. You can't save 3. It's just, you're doing better. Why do you have so much fluids? I don't even know. She's so thirsty. All right. Maybe you need a popsicle. All right. Anyway, let's talk about cards. So, how many cards are in a deck? This you can write down.
52.
This you can write down. 52.
How do you not know that?
Now, the great thing about cards is that I will always give you what there are for cards. I'll say there's 52 cards. I'll say what kind of suits, all that stuff. And if a card question comes up on a test, I'll give you the information. You can call me over and be like, Mrs. Lepp, how many hearts are there? I don't even know. Are they red? I don't know. Hearts, could they be black? Some people's hearts are black, but not in cards. All right. I like
Well,
mine.
especially in cards that their hearts are more.
It could be. I'm vicious with cards. Anyways, now, the great thing about the diploma is if they give you a card deck, they often want it to be not like people who play cards have like a hand up. So they'll make it literally hand up. Get it? So, I didn't even know that just happened. All right. Thank you. So, just so you know, they would give you like a whole totally different deck. There's 16 cards. There's blue, purple, red, and orange. It makes it more annoying for me. But they make it so that it's a level playing field. If you're not a card goer, you're still okay. All right? But we do questions with real cards. So there's 52 cards. There are 4 suits, which means there's 13 in each, because that's just dividing. Okay? Of the 4 suits, I'm going to do this in red. There's hearts and diamonds, which I wrote in red because they are red. It's crazy. Okay, now we're going to get even more crazy. There are 2 more suits, spades and clubs. I should have done these in reverse colors. It would have totally destroyed your hearts. Spades and clubs are both black. So of the red cards, there's 26. Of the black cards, there's 26, which makes sense because there are 52, and we would divide it in half. Okay? Now, our cards go from ace to king. Ace is a 1, so let's go. Ace, 1, right? Then 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. That's how you get the 13 cards for each one. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay? Face cards are the ones with faces. What would have a face? An ace does not have a face. That rhymes. It's not true. Okay? Jack, queen, king are the creepy ones with faces. Okay? Jokers we don't count in our deck. So we have jack, queen, king. We have 4 suits. So how many face cards do we have? 12 face cards. Now cards order doesn't matter. Why? Okay, I just dealt myself a 1, a 2, a jack, a queen, and a king, and it's hearts. So I hold them up and I'm like, okay, put the hearts together, the diamonds together. First thing I do when I get my cards is move them. So did the order matter? No. War would order matter? Yeah. And you just come on, give me something good. Let this be great. I need to pet, War with 2 sucks. There's things like that. So war is the only one I can really think of where when you get the card in that order, you have to play it in that order. But most of the time, you get a card, you can move it around. Okay? So I'm going to do a 5-card hand. 5-card hand. So how many cards am I choosing? 5. Good job. All right. If I just want a 5-card hand, I get the cards and move them around. So I know it's a C, right? As we've discussed, order doesn't matter once you get them. If I just want a 5-card hand, I know I'm choosing 5. Very much, look at me. Look at me go. I'm choosing 5 cards. Woo, great, I did it. I'm so good. How many am I choosing it from, though? 52. Because I didn't specify anything in particular about these cards, correct? 52. And then that would be actually the maximum number of 5-card hands I could have. I would type it into my calculator, call it a day. Now, what if I want 2 queens, and, which means multiply, not add, because that made me sad. 2 queens and 3 tens. I want a full house, per se. Okay? 2 queens. The cards are going to be dealt to you. You move them around all you want. You're seeing what's in your hand. You're just seeing in our hand, what's the chance of us having, I just get all the cards and boom. What's the chance that I have 2 queens and 3 tens sitting in this little hand? Right? Because I can just move them around. I could be like, I don't want them together. And I could just line them up in a different way. Now, it's going to be a C because it's cards. Now, okay, I'm going to choose 2. And, which means I'm going to multiply, although you people keep telling me. 2 queens and 3 tens. Boom. Great. Gotten to that part. Now I just need to figure out how many cards I can pick from. I need to guarantee, yes. I need to guarantee that I get queens. How many queens are there? 4.
You just said you were getting dealt in.
Yeah, which means I can move them around. I'm not laying them down in an order is what I was saying. You're telling me what's the possibility that I could get 2 queens and 3 tens? You have to choose them from their people. You can't be 52 from their people.
Dealt the card.
You can move them around.
It's so complicated.
Okay, you guys didn't fight me when I said teachers and students. You were like, yeah, 40 teachers. I'm going to choose the teacher from the teachers. I'm going to choose the students from the students. If I want queens, I have to choose them from the queens. Yes. And if I want tens, I have to choose them from the tens.
You said we're getting dealt on two. Choosing means you spread out the whole deck and get your 2 queens and your 3 hands.
You are overthinking this like a mad fool. We're just like, we're just trying to figure out how many hands in the whole deck can we get with 2 queens and 3 tens. That's what we're doing. You're doing probability. Stop the madness. No. 4 choose 2 and how many tens? 4 choose 10. Type that into your calculator. Everyone's practicing. Sidetracking talent. He's getting angry. Okay? Bring him down a notch. 4 choose 2 times 4 choose 3. You can type it in just the way it is.
24.
There are 24 hands out of 52 choose 5. There are 2,598,960 different types of hands that would look different, 5-card hands, out of 52, right? They look different. There's 2,598,000. So if we did probability, which we do in 30-2, all you would do is you take these hands, whatever we're finding, and you divide it by the total, the 2 million, and you figure out what are the chances, what's the probability that I could get this. We aren't asked probabilities, that's nice. Okay, what if I say this?
Why are you looking at me? I was Ryder.
2 red cards. How many card hands did I tell you we're picking from? How many cards are we putting in a hand? 5, right? We're doing 5. Now, if I say to you, I need 2 red cards, how many cards do I still need? 3 more, correct? And saying I need 2 red cards is them telling you I need only 2 red cards. So what are they indirectly not telling you? And 3 black cards. So you need to know, you need to always read how many cards you need in a hand. I need 5 cards in a hand. Then they say I need 2 red. If I say 2 red and 3 black, most people will get it right. If I say just 2 red, people are like, all right, 26C2, and then they just hand me the answer. That's only 2 cards, right? I still need 3 more cards. We agree? I need a 5-card hand. So if I need 2 red cards, I'm going to choose 2 red cards, and I'm going to choose 3 black cards. And you can figure out how many I'm choosing them from. How many red cards are there? 26. And then there are 26 black cards. Now this is where it gets a little complicated. Ready? I'm going to say this. First, before I say this, I'm going to say something else. If I told you you got to go to the store store says that you need at least $4 to buy anything in it. Does that mean you need $4 or less dollars or $4 or more dollars? If you need at least 4. 4 or more, correct? So if it says at least anything, like I need at least 2 black cards, then I need 2 or more, correct? And what if I say at most $4? What if I go to I tell you at the store you need at most $4, 4 or less, correct? So think about it in money, and you won't make a mistake. If you think about it in like cards, some people will go the wrong way. So now, if I say 5-card hand, of a 5-card hand, I need at least 3 black. Whenever you read the word at least or at most, this is a cases question. This is going to be, wow, that was a cackle. Did a witch come into our school? Cases question. Jeez. I think that person needs to get hired for witch movies. That was impressive. All right, all the witch movies. So, we have at least 3 black. At least 3 black means 3 or more or 3 or less? 3 or more, correct? So I need 3 black. And when I have cases, I use the word or, correct? Which means I'm going to add my cases. So I need 3 black, I'm going to leave a space, or 4 black, or 5. Why are we stopping at 5, Talon?
Because you're only taking out 5 cards.
Because you're only taking out 5 cards. Now, the catch with each of these cases is these cases all have to have 5-card hands, correct? This needs to have 5 cards to have a hand. This one needs to have 5 cards to have a hand. This one has 5 cards. This case is done. Correct? What do I need to do to these other 2 cases to get 5 cards? Ryder?
Have we been raising our hand also?
Yeah, but Ryder just did because he's got it. So go. What do you need? What do I need to add to this one? 2 red into this one? 1 red. I actually didn't hear Talon. So that one. Okay. So this one I need and 2 red and 1 red. And technically the last one I could say 0 red. But is that help? How many ways can I choose nothing? 1. So I just go there and I choose none of it. So there's no help, right? So I could go plus 0 and 0 red at the back, but there's no point. So now I'm going to go through and I'm going to do this. Plus sign and plus sign. Because it's or. I don't know why I wrote the word and then used an and symbol, but whatever. Okay. So I need to choose 3 black and choose 2 red. But from what? 26 for the black and 26 for the red. Now I need 4 black. 26, choose 4, and 26, choose 1. We agree? Then the black, 26, choose 5. Now people will ask me, why is the number not going down? Remember, when you start a new case, you get all the cards back. When you start a new case, you get all the cards back. Right? So you get them all back. Typing it in. See if we get this right. Everyone should be typing. Not into their phones, because I'm pretty sure that's not helpful. Okay. No. Now this, you guess, this is the greatest one. You don't actually have to put it in brackets. Why? Because it's going to do order of operation first. So it's going to multiply, multiply, and then it's going to add and add your answers. That's the great thing about this. Everyone's typing it in, not just me. I'm really good at these. Was not in high school, but I am now. I apologize to Mr. Bickert because he's my teacher and I sucked at these. Okay, what are we getting? I got 1,299,480.
Yep.
You agree? Okay, I want you guys to try this one out. I need a 5-card hand. At most, 2 clubs. So I'm going to use clubs as 1, and then I'm going to supplement with and not clubs. Correct? So I'm going to, for the first case, if I need at most 2 clubs, I'm going to have 2 clubs and 3 no clubs. So 3 other suits, right? So you're going to have 2, that's right. You're going to have 1, but what I picked this one for a specific reason because people forget the other case. You can have 2 clubs, 1 club, or 0 clubs. Everyone forgets the 0 case. So when you have at most 2 clubs, remember there's going to be the fact of having no clubs would work as well. You could have at most 2 clubs, 1 club, or no clubs. So there's going to be 3 cases. Try this one out. So here you should have gotten 2 clubs, or 1 club, or 0 clubs, and then you have to supplement with not clubs. So it's 2 clubs and 3 others. 3 other suits. Just can't be a club. 1 club and 4 others. It doesn't matter how you write this as long as you don't use clubs. And then this one is and 5 other suits. So we're going to do how many clubs? 13, and I choose 2. And other suits? 39, and I choose 3. Plus, and I get my cards back again. 13 clubs, and I choose 1. Multiply, because and. 39, and I choose 4. Or 13, and I choose 0, which is actually just one way. Times 39, and I choose 5. What do you get for an answer?
2,357,062.
What? Would you get 2,357,000 and then I lost you.
862.
862. I heard 62, so I lost the number. Yeah.
If you don't put the 13 zero thing, you might have a completely different answer, and I get the exact same thing.
You probably just put one number in wrong, and I'll look at it and we'll catch it. Okay, so tonight, this is what I need from you. You have a diploma on Friday. Not this Friday, thank goodness. Next Friday. We're going to continue with comms and perms tomorrow. We're going to go through, and I'm just going to give you an example, give an example, and then we're going to learn how to use the actual formula, because there's a formula that your calculator does every single time that you press those buttons that you don't even know it does. Okay, the NCR formula. Tonight, I need you to pick a unit. I don't care which one. Not radicals, rationals, or other functions unless you want to do those on your own, because I don't have a podcast for them. But like trig 4, trig 5, trig 6, transformations, polynomials, exponentials, logs. In the podcast section on the Google Classroom, there's a podcast review, and then there's the print off you can do, right? You can do the print off and then watch the podcast review to see if you get them right. You need to pick a unit and do it. So no perms and comms stuff. Don't care about that tonight. No breather. That's what you're going to do tonight. Is you're going to pick a review unit and review it. Okay? You don't even have to go that route if you don't want to watch the podcast review. You can view yourself out of the textbook. You can review yourself out of the hand-ins. There's all the different questions, but you need to pick a unit and review it. Now, if you're that person who's smiling, going, I'm just taking the night off, bless your heart. Friday is going to be ugly. Okay? Next Friday. Not this Friday. This Friday you'll be okay. Next Friday. It could be ugly. We don't want it to be ugly. I want you to pick a unit and review. Okay? I'm not checking more if you're doing it because that's on you. But that's what I'm giving you tonight, no homework. Okay?